Uh, Good evening, class. Please give me a minute. I need to get the roll attendance taken, and then I will start the lecture. Okay. Okay. I still have some students left, so let me call out the names, and if you are here, please respond. Okay. Arrow Alvarez. No. Eric Andres. Eric, are you here? No. Andrew King, not here, right? Preetha, Kumar.
I'm
Oh
here.
yes, I saw you. Thank you. Deepika Monga.
I'm here.
Oh yeah. Okay, thank you. Atreyi
Here.
Mukechi. Oh yeah, I saw you. Okay, thank you. Đinh Nguyễn. Đinh.
Yes, I'm here.
Đinh. Is it Đinh or Đinh?
Yeah, then I forgot to change my name.
Đinh hả?
Yeah.
Yeah, okay. John Louis Parano or Poreno, not here. Rylan Drunk. I thought I saw him. Rylan, are you here? Rylan is not here. Okay. Whoa. Okay. All right. So let's see. So how are you guys doing? How was the test? I haven't finished grading the test yet. Okay. But I hope you found it easy. Okay, the problems are, I believe, easier than the homework problems. Right. Okay. So I hope I can get everything graded and figure out the grade and so on by Wednesday. If not the list, you can see your grade. Okay. But I love to return your test also, so you can see what you did wrong, and at some point in the near future, I can go over the test when I have time. If not, then I guess maybe I can go over 1 or 2 problems each time we have some time left. But I promise you that I will go over all the tests that you have taken in the course before you take the final exam. Okay, so you can learn from your mistakes and work on those to improve your grade on the final exam. All right. Okay. So any questions on the lecture from last week, or any homework questions that I can answer for you before I continue section 2, right? 4.2, and then we're going to go to 4.3.
Is there
Oh.
any homework due this week, Professor?
Well, you find out toward the end of the class when I collect. Okay, if I collect any, then it's going to be 5 minutes before the class is over, and you need to scan your homework. Let's see what I assigned last week.
Did you take roll already, Professor?
Yes, I did.
I joined a little bit late. I just came home from work.
Who?
This is Rylan Tran.
Rylan, yeah, yeah, you came late. I cleared you. Okay, so you.
Thank you.
Yeah. Okay. So you guys received my updated tentative schedule, right? In Canvas. So you know, if I collect any homework at all, it's gonna be within the last 2 weeks. All right. So let's say if I collect anything at all, it would be somewhere in here. Okay. All right, so today we're gonna do continue 4.2 because I did not finish the lecture for 4.2, then I wouldn't collect 4.2 today. Okay, because I still, you know, I want to give you a chance to ask questions on any homework. So since 4.2 I will not be able to finish until today, then I give you a chance to ask questions on Wednesday. That means the earliest that I would collect section 4.2 would be Monday next week. Okay, so that's how I do it. I always give you a chance to come to class and ask for help first before I collect it. All right. Okay, so let's continue section 4.2. So again, chapter 4 is about solving higher order of differential equations, but they are still linear differential equations. Okay. So we're gonna first start solving like second order, and then we expand to third order and so on. So last time we did this one. Okay, we did problem 6, right, in the book. So now I would like to do, let me see what I have. I think problem 10. So let me just copy problem 10. So problem 10, again, section 4.2 is using reduction of orders, right, to find a second solution when the first solution of a second order differential equations is given. Okay, so make sure you do the way that I'm showing you here instead of using the formula provided in the book. Okay, because if you use that formula, you will not get credit for it. Just like you know, students who used the formula to find to solve a logistic equation, okay, then you would not get credit for it, because I need you to show me the work, because I want to see if you understand how to do it. All right, so for problem 10, let's read the direction real quick. It says use reduction of order of formula. No, now not formula. Okay, so let's cross this out. So you know, no formula. Okay. To find a second solution. All right. Oh, by the way, this is important. So I want to announce to you that I don't know if you received an email from the college saying that the college has some money for students to apply, like a grant, because the college received, I think, a few $1 million, right? So a couple $1 million to help out the students, okay, as grants, and then around $6 million for professors to apply, like such as like involving technologies to help the students through the pandemic related to instructions, right? So you know, I've been so last week I was very busy with typing up and coming up with things that I wanted to ask for to help my students when we come back and teach in the fall. Okay, because in the fall, some students will be able to physically come to class, not completely, not the entire class, but probably about 15 students can come to class to and be in class with me, and then the rest will be on Zoom. So they take turns. So that is up to the professors to figure out a way to divide out who can come and who have to stay home to learn the lessons on Zoom, and then which days they need to come to class, and then when I give the test, it's just the test, right? Include the final, all of them will have to come to campus. And that is to be worked out, like whether they will have to come into one classroom or in different classrooms, and I will have proctors and so on. So I have to come up with ideas, and I ask for money to buy math softwares, graphing calculators, things like that. So and then they approve that they would move my requests to the next level to be considered, but then they asked me that I would have to go type and give more reasons why I need these and so on. So I've been doing that all afternoon, coming up with reasons because I want to make sure that I get the money to purchase. Okay, so but I hope you take advantage of that and apply if you qualify. Okay, so read the information carefully. When you receive, I think the email sent out sometime this past week, probably on the weekend, I don't remember, but is the money for you guys. Okay, so please don't pass it by. All right, okay, so let's get back to this. Well, some student asking for a test. Everything is written in the class syllabus. Okay, so you can read on there and find out. Because sometimes I don't want to say answer right away because I have different classes, different courses, and they might mistakenly tell you a wrong number of tests. Okay, but I think we have 2 more and the final exam. All right. Because we'll have and I say it on the first page of the syllabus, so you can read that, so you know exactly what the next test will cover and the test after will cover. It says on there on the syllabus, so please read. All right. Okay, so let's go back to here and do this. So we already know the first solution. So now the direction only asks you for the second solution. It doesn't ask you for the general solution. So like what we did over here, we found the second solution and I gave you that note, right? So just in case you were asked for the general solution, then this is how you would write your general solution. You just take a constant times the first solution plus another constant times the second solution. And I use the capital letter C's, right? I think the book, the author uses the lowercase c, and I like to write the bigger letters so they stand out. All right. So now, the first step again is to let the second solution be a u, right? Some function u of x times the first solution. So in this case, the first solution is x squared, right? So you write, so let's write down, you can write u, let's just write u knowing that u is a function of x and then times x squared. Okay, so now we want to know what the second solution is, the derivative of the second solution is, so we can plug them in into the differential equation. So you go to the second step and you find out what the first derivative of y sub 2 is. So y sub 2 prime. So here is y sub 2, which is a product of these two, right? So you just use the product rule, which is the first times the derivative of the second plus the second times the derivative of the first. And of course, the derivative is the derivative with respect to x. All right, so let's rewrite. So that gives you 2xu plus x squared u prime. All right. So let's go to y sub 2 double prime. So let's deal with this one first. So that is also a product. So I'm going to take 2x times u prime. Okay. So 2x times the derivative of u plus u times the derivative of 2x, which is 2. So that is 2u. Okay. So that's what I have for the purple term. Now for the blue term, then you have the derivative of a product. So that's x squared times the derivative of u prime, which is u double prime, right? Plus u prime times the derivative of x squared, which is 2x. All right, so that's what I get from the blue term. So let's see if they are like terms. And yes, they are like terms, so I can combine them. So I have x squared u double prime plus 4xu prime plus 2u. So that is y sub 2 double prime. Okay, so now we're gonna go to the third step and make our substitution. I don't know if I wrote third step. Yes, no. Okay, so now we just use the substitution. All right, so now I just say, all right, so that we'll go to here. So we're gonna make our substitution. So we have x squared and then y double prime sub 2. I'm going to write it in red. Okay, so that is x squared u double prime plus 4x u prime plus 2u. And then plus 2x times y prime. So y prime is 2xu plus x squared u prime. All right, and then minus 6y. So minus 6y and y is ux squared, or you can write x squared u. Okay. Which is equal to 0. All right, so now let's multiply out. So what do we have? So if you multiply out, that will give you x to the 4th u double prime plus 4x cubed u prime plus 2x squared u. All right. Okay. And then now you multiply the 2x out, you get 4x squared u. I'm gonna combine like terms, so this is how I would do it. Okay. No, that's okay. Just right. Okay, so plus 4x squared u. But here's how I would normally do. I would put it right here. Plus 4x squared u. See, as you multiply out, you know that you're gonna get a lot of terms. So you want to gather like terms at the same time. So that will help save some time for you. So that will give you this, right? Okay. Okay. So let's continue on. And then 2x times x squared u prime. That will give you 3x cubed u prime. Okay, so I have x cubed u prime right here. So I'm going to write plus 2x cubed u prime. Okay, so that's what I got from multiplying these two out. And then I have minus 6x squared u. Is there a 6x right here, right? 6x squared u. So you multiply, you get minus. So let's use what color? Let's see if there's a good color. Let's use this pink. So minus 6x squared u. All right. So everything there is equal to 0, of course. So everything there is equal to 0. Okay. So from here, so let's see what we have. So we have x to the 4th u double prime plus 6x cubed u prime. That's it, right? Plus 0. So that's 0. Okay. So now you're gonna try to solve for u, right? And from what I showed you in the previous example, you're gonna try to use a substitution so you can turn this differential equation into a first order differential equation. Okay, so from here you just go to the right and you let w be u prime. Okay, then that will give you dw du, right? dw du to be u double prime. Okay, so let's do that. So you go back here, you have x to the 4th, that is dw. Let's do this. So dw. No, I'm sorry, dw dx, not dx, because u and both. Okay, and then plus 6x cubed u prime is w, and then equals 0. All right, and see if you can separate the variables. And yes, I think we can do that. So this is 4 x to the 4th dw, and you move that 6x cubed w to the right, and then you multiply by the dx. You put the dx over, and then so that gives you that. Okay, so now you just integrate both sides. So when you do that, then this will give you ln of the absolute value of w. I don't know why I get the green. Okay, and on the right side you get negative 6, and then ln of the absolute value of x plus a constant. I don't know how many constants involved, so I just use c sub 1 for now. And then at this stage you can exponentiate both sides. So now you can exponentiate, right? Okay, so you can exponentiate both sides. So when you do that, then you have that, and then e to the c sub 1 times e to the negative 6 ln of the absolute value of x. Okay, so what you have now is w is equal to positive and negative e to the c sub 1 times e to the ln of this. Okay, so what you have now, that gives you a constant c, and I call it c sub 2. And right here, e and ln cancel out, so times the absolute value of x raised to the negative 6th power. Now, so you see, in this case, you can drop off the absolute value. You don't need it. See, the reason why we need the absolute value is we need to make sure that this x is always positive, right? However, right here, you are raising to an even power. So it doesn't matter if x is positive or negative. You're going to get a positive number anyway out of that. So that's the reason why you don't need the absolute value anymore. So it is important for you to understand when you can throw away the absolute value and when you can't, okay? So this is what you have. Yeah, you can make a note if you want to. This is since negative 6 is an even power, so it doesn't matter if x is positive or negative. When you raise it to an even power, you always get positive. All right, so now W is U prime, right? So W is U prime. So this is what we have. So you can get the you can separate the variables again. So you can see when you learn something new from a section, pay attention to the examples, and also pay attention to the homework that you do, right? Because you notice that when we do this, when we go to the third step and use the W for the substitution, we were able to solve that resulting differential equation or that integral. Or we were able to solve that resulting differential equation by separating the variables. And that happened again here, right? We were able to separate the variables. And right here, another one, you can also separate the variables here. So you have du equals c sub 2 times x to the negative 6th power dx. And then you can find u. So you see the objective is to find out what u is, because your second solution is some function u times the first solution. So just find out what the second solution is. So right here, you can just integrate. Oops. So that gives you u equals c sub 2, and the integral of this is x to the negative 5th over that, and then add a constant because you just found an indefinite integral, right? So remember, there are so many different u's that you can use. Right here, there are so many different u's because for any variables, for any constant c sub 2 and c sub 3, you're going to have a different u, right? So you want to get the simplest one, and the simplest one is what? So from here, you choose c sub 2 to be what?
0.
C sub 2 to be 0?
To 1.
You choose c sub 2 to be 1. How about c sub 3?
0.
Okay, so you choose this to be 0, but you want c sub 2 to be 1.
Yeah.
Okay. Is there a
Negative
better
5.
value for c sub 2?
Negative 5.
Yeah, negative 5. So you put it right here, you
Oh,
cancel with that.
okay.
See? So it looks nicer, right? Okay. I know you want to be a little bit more sophisticated. That's okay. I'm a simple guy, right? I want to get a simple function. So I choose that to be negative 5, right? And c sub 3 to be 0. So if you do that, then what is u? U is going to be x to the negative 5th power. You see that? So, okay, so let's say u to function u. Okay, so what is your second solution? So y sub 2 y sub 2 is u of x times y sub 1. And u of x is this, right? And then y sub 1 is equal to x squared. Okay. So what is y sub 2? So the second solution is this. Okay. Any questions? And we're done. All right. So again, if I ask you for the general solution, then the general solution is going to be y equals a constant c, say c sub 1 times the first solution, which is x squared, and then plus c sub 2 times x to the negative third power. Okay, and remember the c sub 2 that you have in the general solution has nothing to do with the c sub 2 up here, okay? Because these are for you to get the u. And the constant c's in your general solution would be any arbitrary constants, just like how we got them right here, right? Okay. So far so good. Oh, by the way, I also asked for a webcam, a portable webcam. I hope they will approve it, because see, when I fold down to write, you don't get to see my face, right? Okay, because when in class, when you take class in person, you want to see your professors, because sometimes I make gestures, right, that will help you understand. Like I do this, do that, I'll hand, waving. So so I asked them for a webcam and explain that why, and because some of them said, okay, we have webcams available for you to check out and use, but I said those webcams are not good webcams. Those are just to see the face, right? Because I have a webcam that will stay in focus when I show something small in details, like I point something to the book, or I have something on my calculator, and I want to be able to put it in front of the webcam and you can see it clearly. So the portable webcams that you guys check out or borrow from the campus, they are not good enough for those things. Okay, so okay, so now we're gonna go to section 4.3. Okay. Now, by the way, how many sections did I upload for the lecture notes on Canvas for chapter 4 already? If you downloaded them, okay, because I want to make sure that now, just in case, okay, please remind me, just in case you don't see me upload some lecture notes for the next class meeting, then please remind me, okay? Maybe there are no lecture notes for the next class meeting, but sometimes they are and I forget. Okay, so please let me know, because I don't want to come to class and say, all right, we're going to lecture section 4.3, and then you don't have the lecture notes, and that section 4.3 happens to have a lot of stuff on there. So now you have to get up and download the lecture notes and print them out, and it's a waste of time on your end. Okay.
Right now for chapter 4, you have up to 4.6 posted.
Up to 4.6. That's
Yep.
good. That's good. Okay. So how many sections are there in chapter 4? We have 6, 7, 9, and 10. Okay. So I still have 7, 9, and 10 to upload, right? We skip section 4.8. We don't need to know 4.8. Okay, great. Okay, so let's get back to chapter 4, section 4.3. So 4.3, okay, we learned this. So today in 4.3, we're gonna learn homogeneous linear equations with constant coefficients, okay? And then later on in the chapter, we're gonna learn homogeneous linear equations with variable coefficients, right? So this is easier. Now, before we go down, can you tell me again what it means by a homogeneous linear differential equation? So when you hear homogeneous differential equation, what are you thinking of?
Professor, you're not sharing your screen.
Oh, I'm not sharing the screen? Okay, great. Okay, thank you for telling me. Okay, you see it now, right? Okay, but you should be able to answer my question without seeing this my screen. Okay, what does it mean by a homogeneous differential equation? You need to know the terminology. Okay, it's very important. Everything was we talked about those in section 4.1. A homogeneous differential equation is a differential equation where the right-hand side of that differential equation is 0. Okay, so basically that function g of x is 0. Okay, it doesn't allow me to scroll up and down. Now it does. It's crazy. Oh, why do I have that little hyphen? Yeah. Okay, I need to. Okay, I don't know why that hyphen is there. Okay, so homogeneous means the right side here is 0. Right here, you see? The right side of the, so the function of the independent variable on the right side is 0. All right. And now on the left-hand side, you have the coefficients. Remember, we used to write like a sub n of x, which is the independent variable, and then a sub n minus 1 of x and so on. But now I don't write of x because now these coefficients are constants. All right. So you need to understand the title, okay, of that topic. Okay. So what are some examples of homogeneous differential equations? So here are some examples. For example, you could have like y double prime plus 3y prime minus 4y or minus 4, okay? Minus 4y equals, and the right side has to be 0, okay? And here is another example. You could have like 6, which is a constant, y triple prime, right? Minus 5y double prime minus 4y prime plus y equals 0. Okay. So you have, so those are considered homogeneous differential equations. And they are linear because the dependent variable and its derivatives are all raised to the first power. All right. So now, let's recall what we have done so far. Now that looks like a population growth or radioactive decay, right? Instead of P, we use Y here. And we have done that many times. So if you recall this one, can you tell me what the solution of that is when you separate the variables and solve?
I think it's KYX.
C e to the GZ KX. Okay, that's what we did. Oh, that's what we got, right? When we solved the differential equation on the left-hand side by separating the variables. Okay, so let's suppose we have a homogeneous differential equation in first order. Okay, so I'm just trying to write like this. So from this general homogeneous differential equation here. So suppose we only have the first order, which is just this, right? Just that. So this is what we have right here. So we have like a constant times y prime plus a constant times y equals 0. So let's see what the solution looks like from this first order. Okay. So this first order, when you write that on the right hand side, you get, when you isolate the y prime, you get negative b over a y. Okay. And then so that looks like this, right? That looks like this. So your k is actually negative b over a. So you know the general solution of this one is y equals c e to the negative b over a x. Okay. But let's say you didn't know that. Okay, let's go ahead and go through the steps. So you're gonna separate the variables. And then you integrate both sides. So that gives you ln of the absolute value of y, and on the right is negative b over a plus a constant c. Let's call it c sub 1, all right? Okay, and then you're gonna exponentiate both sides. So you exponentiate the left and the right. So that will give you this. And on the right, you have that times e to the negative. Oh, I'm missing, you guys didn't catch my mistake, huh? This line right here. What am I missing?
It should be over ax.
Right, and then x, like that, okay? Please don't write like this, okay? Because some students, they write like this, ax like that. It just looks very improper, all right? Okay, so that's why when you use a slash for a fraction, you have to know what you're doing. Okay, so if you write like this one right here, okay, then make sure you put parentheses around the negative b over a. Okay, so that is b a x like that. All right, so if you want to solve for y, then you have to remove the positive and negative. So the absolute values, you have positive, negative, e to the c sub 1 times e to the negative b over a x like that. All right. So what is so if you want to, you can just make it look nicer. So you can just write a little bit farther. Bring it down. Okay, so it looks nicer. All right, so from here, y is equal to a constant c, because that is just a constant c, and then e to the negative b over a to the x. All right, so why are we doing this again? Well, the first reason is so that I can help you review how to solve a first order, right, homogeneous first order differential equation. Okay, now again, we have always talked about just linear differential equations. So if I don't mention linear, I mean linear, right? So you know that the solution of the first order of the homogeneous first order differential equations is some exponential function. Okay, so it's like e raised to some power, some number times the independent variable. So now the question is, then what does a homogeneous linear second order differential equation with constant coefficients look like? Okay, so now we're gonna look at the second order. Okay, so this is what happens. So mathematician says, well, since the first order give us a solution of the form e raised to a number times the independent variable. So let's try and see if we can come up with something similar to that from a second order differential equation, okay? So maybe they are related. So let's just give it a try, right? Because at first, when you don't know anything, you just explore, right? You just try something and see if you get something interesting. So what they do is, okay, so how about assume that the solution of this second order also has the form e. So I'm going to write right here, okay? So e raised to some number, and we use the m, right? Some number times the independent variable. So we would like this differential equation to have a solution of this form. All right, so if it has a solution of this form, then when you find the first and the second derivatives and plug them in here, they better satisfy this equation, right? So let's do that. Okay, so my y is e to the mx. Then when you take the first derivative, you're going to get m e to the mx. And when you take the second derivative of the first derivative, you get m squared e to the mx. So now we're going to plug them in to this differential equation. So we have a, and then y double prime is m squared e to the mx plus b. Y prime is m e to the mx plus, and then cy. Now this is a lowercase c, right? So lowercase c, and then y is e to the mx. And then on the right hand side is 0. Okay. So you multiply everything out. So you look at the three terms. Look at this term, and this term. All of them have a factor of e to the mx in common. Okay, so you factor that out. So what you have left would be a m squared plus bm plus c equals 0. So here you have a product. You have a product right here. You have a product that is equal to 0. So that means this would be, so that means this would be 0 or, oh, not x, I'm sorry, it's m. Okay, so that's what you would get. Let me write again. But do you think this will ever be 0? This exponential function right here. Will that ever be 0?
No.
No.
No, it can never be
right?
0.
Because when x is very big, it is approaching 0. Agree? So if m is positive, if m was negative, the graph is like this, right? The graph is like this if m is negative. So whatever x is, it will always be positive, and it will get close to 0 when x is big. If x is positive, the graph is like this. But here's the x-axis. Okay, so it will never touch the x-axis. So you know that will never be 0. So you're going to cross that out. So this is impossible. That means this must be 0. Okay. So if you can solve this equation, well, that is an that is an exponential, that is a quadratic equation. So you can solve that for m. How many values do you think you can get from m?
2.
2, right? Because it is a quadratic equation. So you call it, it's going to be m1 or m2. Okay. So there are 2 values for m. So you know that y is going to be equal to, so the solution, so this equation has 2 solutions. Because see, you look at the order, that is second order. So you expect that to have 2 solutions. And yes, you get 2 different values for m. So you have the first solution is e to whatever that first solution is times x, and then the second solution is y equals e times e raised to the second m times x. So there are 2 solutions. Okay. Now, this quadratic equation right here, does it look kind of like this differential equation in a way? Can you avoid all of this work? And by looking at this differential equation, we can get this equation right away. Can you? What is the difference between this one and this one? What would you do with this to get this without showing any work? You have no clue? Here's A, here's A. A. How do you get m squared? This y, the second derivative is squared. The first derivative is just m to the first. And for the m, for the y, you don't have anything, okay? Because y prime is m. And y double prime is m squared. So y is m to the 0 power, you see? So the m is like the y. And then the order of the derivative is like the exponent of m. Okay? So the second order is square for m. The first order is first power for m. Y to the 0 power is just like m to the 0 power, which is 1, right? So that's how you get that equation. This is a very, very important equation, okay? And we call it an auxiliary equation. Okay, so this is equation of the second order differential equations. Okay, so it's very important for you to know this. So whenever you want to solve a homogeneous linear differential equation, you need to find its auxiliary equation and then solve for m. All right. So here we only concentrate on the second order, because if you know how to do it for the second order, then the third order and higher and any order higher should be similar. It might require more time, okay, to get the m, but the concept is the same. All right. So once you have the 2 m's, then you know the first solution is going to be e, because the solution is of the form e to the mx, right? So it's going to be e to the m sub 1x. E to the m sub 1x. And the second solution is e to the second m value, which is m sub 2x. So from section 4.1, then we know the general solution of this differential equation is a constant times the first solution plus another constant times the second solution. Now that gives you y equals c sub 1 e to the m sub 1 x plus c sub 2 e to the m sub 2 x. Okay, so that is how you get the general solution of that second order homogeneous second order differential equation. Now, there are three cases because when you solve this quadratic equation right here, okay, imagine if you use the quadratic formula, okay, if you use the quadratic formula and solve for m, there are three cases. Case number one, these two m values right here might be the same. That means it is repeated, right, twice. That means it has a multiplicity 2, all right? Or these two m's are distinct, right? So they are different, but still real numbers. Case number 3 is these two values right here could be complex numbers, okay? So let's consider, okay, consider the solutions of that auxiliary equation, okay? And the equation that we are talking about is this equation right here. So let's write it. So that is am squared plus bm plus c equals 0. That's what we are talking about. Okay, so we want to look at the different cases of this auxiliary equation. Oh, I'm gonna write it down again. Okay, so I guess it's down here. You can put it down here. All right. Okay, so case number 1. We may have distinct roots, right? So it has two roots. Now, so distinct roots means, now you told me that the equation would have two solutions, m1 and m2. So we want to look at case number 1 when m2 and m1 are distinct. That means m1 is different from m2. So if they are different, then the solutions, the two solutions of the differential equation are, we just wrote it up there right above that. I'm going to write again, which is this. All right. Now, case number 2. What if this equation has a repeated root? That means m1 and m2 are the same. Okay. So m1 and m2 are the same, which means okay. So this is like, okay, so repeated roots, right? So repeat, or you can say with multiplicity 2, right? So how do you write the solutions? Okay, so if they have the same value, then at least you know one solution. Okay, then the two solutions are y1. Okay, so I'm gonna write y1, which is e to the m sub 1x. And what is y sub 2? Okay, so if you don't know, of course, in this case, we don't have another value for m. So how do we find y sub 2? You already know one solution. Can you get the second solution? And how do you get this? How do you get the second solution once you know what the first solution is? Can you tell me? I need some help from you.
Use the reduction thing that we learned.
Okay. All right. So make sure on the test you write the correct name. All right. So, but I understand what you meant, right? The reduction thing. That means the reduction of orders. Okay. Now, like I said, this is like a foreign language class, right? You have to know you have to know the vocabulary, okay, and the terminology. So once you have the first solution, then you say we can use reduction of orders in section 4.2 to find y sub 2, okay? And when you do that, I'm not going to do all the work, okay? You do all the work to verify that. But after you use reduction of order, just like how we did it here, right? Like similar to problem 10 and problem 6 of section 4.2, then you know that the solution or the second solution is going to be, where's my 4.3? Right here. It is going to be an x. It's going to be an x value. So that's your u, okay? So you're going to find a u, right? So the u is x, and then you multiply it to the first solution, which is e to the m sub 1x, okay? All right, and then you can just make a note if you want to. We can use reduction of order to find y sub 2, okay? So you need to know the different cases, all right? So, you know, like distinct roots, then how you get the solutions, repeated roots, how you can get the solutions. Now, for example, in this case, if this differential equation was the third order, then you know that you will get 3 different values for m, right? And let's say those 3 different values happen to be the same. That means m is equal to m sub 1 with multiplicity 3. That means 3 times. Then the third solution is going to be x squared and then times e to the m sub 1x and so on, okay? And you can use reduction of order again, okay, to find the third solution once you have the first and the second solutions. It takes more time, okay? Now, so the first 2 cases are easy. The third case is the more complicated one. And that is when the roots or the m values are complex numbers, okay? So if they are complex numbers, then they would look like this. Then m sub 1 is equal to like a complex number, alpha plus beta I. And m sub 2, you know that it's going to be the conjugate, because when you solve a quadratic equation, you're going to have like negative b plus minus square root, right? And that square root gives you an I. So you know that if you have a plus, so alpha plus beta I, then it's going to be alpha minus beta I, okay? All right. So these two solutions, or these 2 values of m, are distinct, okay? Because they are the conjugates, they are not the same. So if they are distinct, then you can write the solution like this, okay? So y1 is equal to e raised to the m1, which happens to be alpha plus beta I, and then y2 is equal to m e raised to the m sub 2x, which m sub 2 is alpha minus beta I. Okay, so let's write that down. Okay, so the 2 complex solutions of star are y1 is equal to e to the m sub 1, which is alpha plus beta I x. And the second solution is e to the alpha minus beta I x. Okay. But the problem is when we want to find solutions of a differential equation here, we want the solutions to be real solutions. That means solutions that are real numbers. In this case, these two solutions will not give you real numbers. They give you complex numbers. Okay, so let's say, but okay, I'm gonna write in red. Okay, we want real, not complex solutions. Okay, so if you want real solutions, how can you get the real solutions from these two complex solutions? Okay, so before we can get we can obtain two real solutions from these two real complex solutions, I'm going to take you back to trigonometry. There is a formula in trigonometry, we call it the Euler's formula. And the Euler's formula, okay, is when you have e raised to some real number times I, which is the imaginary number, that gives you cosine of that theta plus I sine of that theta. Okay, so that's what Euler's formula is. All right, so I don't know, should I, yeah, let me use this. Okay, so here are the two solutions, right? Complex solutions. Let's write the general solution. Okay, so the general solution would be c sub 1 y equals c sub 1 y sub 1 plus c sub 2 y sub 2, and then we're going to plug them in. Okay, so let's go out here. Let's see if we have, okay, so y is equal to c sub 1. Let me write a little bit bigger. And y1 is e to the alpha plus beta. No, beta I x plus c sub 2 e to the alpha minus beta I x. Now remember, if we have an e raised to a power that has I, we're going to use Euler's formula to make our substitution. Okay, so here's what we have. So this one right here is equal to c sub 1 e to the alpha x times e to, let's write, I beta x. All right, I write the I first, so it looks like this. So it looks like this one right here. And then the second one is c sub 2 e to the alpha x times e to the I, or I, and then let's write the minus. So it's minus. You know what? Let's do this. I, and then my negative beta x. So far, so good? All right. So now you see that these two terms have e to the alpha x in common. I'm going to factor out e to the alpha x. Okay. So e to the alpha x. And on the inside, I have c sub 1. C sub 1 times this. Okay, times c sub 1 times e to the I theta. Theta is bx. So if you have e to the I theta, e to the I theta is cosine of theta plus I sine of theta. So this is going to be cosine of beta x plus I sine of beta x. All right. So I'm going to write that. So I like to use a brace here. Okay. And then c sub 1 times e to the I beta x is cosine of beta x plus I sine of beta x plus, and then c sub 2 times. Now for this one I remember I already factor out that one, right? So now I have this, and this one is let me write. So that is I theta. So theta is negative beta x. So if I see theta, I replace theta with negative beta x. Are you following? Okay. So that is going to be cosine of negative beta x plus I sine of negative beta x. That's what I have. Okay, so let's simplify. So I have e to the alpha x. Okay, and then I'm gonna multiply. Well, let's let's multiply out. Let's multiply out. So that's c sub 1 times cosine of beta x plus I c sub 1 sine of beta x plus. Now, you know that in trigonometry, this is the same as cosine of beta x, right? Because cosine is an even function. So cosine of a negative angle, like cosine of negative 30, is the same as cosine of 30 degrees, okay? So when you multiply that out, you have c sub 2 cosine of beta x. And this one right here, you know, in trigonometry, sine is an odd function. So sine of negative angle is equal to negative sine of the angle. Okay, so that's going to be negative. All right, and then I c sub 2 sine of beta x. All right. So far, so good. So now, let's see if we can combine any like terms. So we have, let's see, this term and this term, okay, are like terms, right? Both have cosine of beta x. So I can combine them to get c sub 1 plus c sub 2 cosine of beta x. So I combine those two to get that, okay? Now, plus, see this and this one, we can combine them because both have sine of beta x. So I have like IC sub 1 minus IC sub 2. So I can just factor the I. And then C sub 1 minus C sub 2. And then sine of beta x. Okay. So remember, our goal is to get two real solutions, right? Okay, so the next couple of steps can be a little bit confusing. Okay, so when you okay, so that's what we have. Okay. Oops, let me try to use this so you can see how we get this term. Okay. Now C sub 1 plus C sub 2 is just some constant C, right? So we don't want to write C sub 3. Okay, let's just say we're gonna write if you want to, we can just write A. Okay, let's just say A. All right, so A, and then cosine of beta x. All right, and then we have I, and then these right here, C sub 1 minus C sub 2, just call it B, and then sine of beta x. All right, okay. So if you rewrite, so y, if you multiply the e to the alpha x out, what you have is this, a e to the alpha x cosine of beta x plus I b e to the alpha x sine of beta x. Okay, so here is a complex number. In algebra, you call this the real part of the complex number, and this is the imaginary part. Okay, so right here. So that is the real part, and that is the imaginary part, okay, of a complex number. Okay. So I don't know where I should write. You can just make a note somewhere, somewhere over here. Okay, just make a note somewhere over here. When you have a complex number, okay, so complex number. Like a plus bi, okay, that is the imaginary, that is the real part, and that is the imaginary part, and those are real numbers. Okay, those are real numbers. Okay, so these a and b are real numbers. Okay, so with that said, then these and these are real functions. Okay. Okay, let me write a little bit bigger so you can see. Okay. Oops. Okay, let me use this. Okay, so those are real functions. Okay, right here. Right there. So it looks like a plus bi like this, right? So so there are two real functions here. Okay, and this is the general complex solution. Okay, so let's write this. So this is This is the general. Of complex solutions or solution of these differential equations, okay, okay, for case 3. And that is when you get complex numbers for m, okay? So but we don't want to have complex solutions. We want to get 2 real solutions, because you know that this differential equation right here is a second order differential equation. So you expect 2 real solutions. So the 2 real solutions are these right here. So, you know, without the numbers, right? So the 2 real solutions are, the first one is e to the alpha x cosine of beta x. And the second one is e to the alpha x sine of beta x. So those are the 2 real solutions. Okay, those are the 2 real solutions of case number 3. And you know, we want to get the complex, right? We want to get the general real solution, right? So the general real solution is y equals a constant times y1 plus a constant times y2. Okay, so you just use a constant. Okay, so c1 times y1 plus c2 times y2. Now remember, this c1, so these c1 and c2 are not necessarily the same as the c1 and the c2 that you have up here, okay? Because, you know, you can use, these are just dummy variables. You can use any letters you like. We happen to use c1 and c2, like how we did it for all the cases. So we can use case c1 and c2 again. So let's plug them in and see what we have. So y equals c1. Okay, c1 is y1 is e to the alpha x cosine of beta x plus c2 e to the alpha x sine of beta x. Okay, so if you factor out the c sub 1, the e to the alpha x, then you have this. Okay, so this is a real solution. Okay. All right, so let me highlight this. So this is how you write the general solution when the auxiliary equation gives you 2 complex solutions. Okay, and this is and then over here, this is how you get the 2 real solutions when the roots are repeated. And this is how you get the 2 solutions when the roots are distinct. Okay, so case 3 is a little bit more involved. Okay, so case 3, that is the general solution. Okay, so the general solution. So the general solution, real solution, is that. Okay, so let's do some examples. So problem 4. I give you that differential equation. And what does it ask us to do? Find the general solution of the given second order differential equation. So that's straightforward, right? So what are the steps involved? So you have that differential equation. You know that it is a homogeneous differential equation. So the first step you do is you get the auxiliary equation. So that means you see the coefficient here is 1. So A is 1. So A y double prime means m squared. So that's 1 m squared minus 3 y prime is m to the first plus 2y means 2m to the 0 power, which is 2. So that is the auxiliary equation. Now you're going to solve this equation. So to solve this equation, well, here it is easy. You can factor out. So m is equal to 1 or 2. Okay. So in this case, you know that these are 2. So these are like 2 distinct roots, right? Okay, so you can get your y1 and y2. So what is y1? So y1 is equal to e to the m1x, which is e to the 1x. And y2 is e to the m sub 2x, which is e m sub 2 is 2. Okay, so you have 2 solutions. But the direction says find the general solution. So the general solution is y equals c sub 1 y1 plus c sub 2 y2. Okay, so y is equal to c sub 1. y1 is e to the x plus c sub 2, and y sub 2 is e to the 2x. So this is the general solution. Now, how do you know that that is the correct answer? Well, you can check, right? You learned it in from chapter 1. You can just find out y prime and y double prime, and then you plug everything in here and simplify, and then you will see that the left-hand side is equal to 0. Okay? So you know that that is the solution. All right? Any question? Okay, so now let's go to the next one, problem 14. So let's see the direction. Problem 14, same direction, right? So solve to get the general solution. So make sure you read the direction carefully, because if they ask you to find the 2 solutions, then just find y1 and y2. So y1 and y2 would be y1 equals e to the x and y2 equals e to the 2x, and you're done. But if they say find the general solution, then you have to go one step further, and that is to write the general solution as a constant times y1 plus a constant times y2, and then you rewrite, okay? And then when I give you an IVP, right, an initial value problem, that means you have to use the conditions given to plug in here to find out what C1 and C2 are to get a particular solution, okay? This is the general solution. So when you have an initial value problem, then you can use the given conditions to plug in to get the initial value problem, to get the particular solution. So let's review quickly the steps. Step 1 is to get the auxiliary equation. Step 2 is solve for m. Step 3 is to find the 2 solutions. Step 4 is to get the general solution, okay? So let's go to step 1. So step 1, we get 2m squared minus 3m plus 4 equals 0. Now step 2 is to solve. Now in this case, it is not factorable. Okay, so you're gonna use the quadratic formula. So m is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, you have negative, and then b is negative 3 plus or minus b is negative 3 quantity square minus 4 times a is 2 times c is 4, and then all over 2a. So a is 2. Okay, so you simplify that, you get 3 plus or minus, and that gives you negative 23 all over 4. Okay, so m is equal to it. You have complex numbers here, right? So you write in standard form, which is 3 over 4 plus or minus I square root of 23 over 4. Okay, or you, if you write like this. Okay, if you write 23 over 4 and then the I on the outside. Okay, so you have complex. So you have complex roots. All right. So if you have complex roots, then you know that they involve like an alpha, beta. Okay, so you know alpha, right? So alpha, beta up here. Let's go through. Right, so M1 is alpha plus beta I, M2 is alpha minus beta I, right? But you know that the two real solutions are like this: y1, y2, yeah, y1, y2 like this. So you have to identify the alpha and the beta. So the alpha, so this is your alpha, and this is your beta. So this is your alpha, and this is your beta. Okay. So step number 3. The two solutions are the two real solutions are, okay, y1, let's write down, y1 equals e to the alpha x times cosine of beta x, and y2 is e to the alpha x sine of beta x. That means y1 is e. Wow, you have to be careful on how to write this one. Okay, so it's 3/4. So you write, you can write, let's write y1 is e to the 3/4 x, and then cosine of beta, which is square root of 23 over 4x, and y sub 2 is e to the 3/4 x sine of square root of 23 over 4x. Okay, so step number 4. Okay, the general solution is what? Well, you just multiply this by a c sub 1, multiply this by c sub 2, and add them up, right? But when you add them up, you see that they have e to the alpha x in common. So just like how you wrote it right here, you see? So you just factor out e to the alpha x, and then you have to sign the cosine in here. So the general solution is y equals e to the alpha x times c sub 1 cosine of beta x plus c sub 2 sine of beta x. And that is the general solution of this given differential equation. Okay. So let's go to problem 18. Now we're gonna solve a third order differential equation. Okay, so problem 18. Find the general solution. Okay. So same steps. Step number 1. Get the auxiliary equation. So the corresponding coefficient of y triple prime is 1. So 1 m what?
Cubed.
Cubed. Good. Plus 3 m squared minus 4 4m minus 12 equals 0. And then the second step is to solve this. Now, so this is something that you you have to know. Remember how to solve that you learned in pre-calculus, right? So it's, or even in algebra 1, beginning algebra. Okay. So sometimes you can factor out, do so. Sometimes you have to use synthetic division to get a 0 and so on, right? Or you learn how to find the rational, all the possible rational zeros and stuff. So now you see that you need to know how to solve a non-linear equation in algebra, okay, or in pre-calculus. So I'm going to take that to the side and see if I can factor that out. Okay, so I'm going to do that on the side. Okay, and see if I can do that. So I'm gonna try and factor out by grouping. So m cubed plus 3m squared plus, and then this is negative 4m minus 12. So the first group, they have an m squared in common. So I hope that the second group also have an m plus 3 in common, and yes, they do. So I factor out negative 4, right? So from here, both have m plus 3 in common, so I get m squared minus 4 in here. But m squared minus 4 is a difference of 2 squares. So I can factor out m plus 2, m minus 2, okay? With all that work, now I go over here and I say that is m plus 3, m plus 2, m minus 2, okay? So you set each one equal to 0, so you know m is negative 3, negative 2, or 2. So you expect 3 solutions because this is a third order differential equations. So you know that the roots are distinct, so there are 3 solutions. So the 3 solutions are, so y1 equals e to the negative 3x, y2 equals e to the negative 2x, and y3 is equal to e to the 2x. Okay, so after you get used to the steps here, you just do it very quickly. Okay, and then the last step is, so the general solution is y equals c sub 1 e to the negative 3x, right, plus c sub 2 e to the negative 2x plus c sub 3 e to the 2x. And you have your answer.
Professor,
Yes.
I was wondering if you could scroll up a little bit to the first step.
Right there. Right?
Thank you.
You're welcome. Okay. Now let's go to problem 24. This time we deal with the fourth order differential equation. Okay. So again, step number 1, you have m to the 4th minus 2m squared plus 1. All right, so now you need to factor this out. Okay. So how's that? So let's go to the side and see if you can do that. That should be easy. M to the 4th minus 2m squared plus 1 is actually m square minus 1 quantity square, right? Or you can write like that. Okay. So that is m plus 1, m minus 1. And then you have m plus 1 and another one. Okay, so okay. So that gives you can just write like this. So that's m plus 1 quantity square, m minus 1 quantity square equals 0. You know that this is a 4th degree polynomial. So you expect 4 solutions, right? But in this case, you get m equals -1. Okay. And what else? That is repeated, right? Repeated twice. Okay. Or m equals 1, repeated twice also. Okay. All right. So how do you write the solution? There are 4 solutions. So y1 is equal to e to the -1x, but it the root repeats twice. So the second solution is going to be x, e to the -1x. You see? And then when m is equal to 1, you get y sub 3 is equal to e to the 1x. But 1 repeats twice. So the next solution is x.
Oh, so Professor,
Yes?
if a variable was repeated 3 times, would it be x cubed?
No, x squared.
Or x, yeah, that's what I meant.
Yeah, you increase the power 1 at a time, right? So if it repeated 3 times, then you have the next one is going to be x squared and then e to the x. If it is 4 times, then the fourth one is going to be y equals x cubed. Okay?
Okay, got it.
All right. So the general solution. is y is equal to c sub 1 y1 plus c sub 2 y2, and y2 is x e to the negative x, and then c sub 3 e to the x plus c sub 4 x e to the x. Class, can you hear the music, a music back in the background on my end?
No.
No, I can't.
No. Okay. If you do, then I'll tell my wife to turn it down because she's downstairs with the music from the TV on. Okay. So we have 4 minutes. So let's do the last one. Okay. So the last one, let's see what that is. Problem 50. It says, find the homogeneous linear differential equation with constant coefficients whose general solution is given. So now we'll do the reverse. Okay, we'll do the reverse. So you see the reverse? Let's look at this. Let's look at an easy case. Okay, so here you have a differential equation, right? You get the auxiliary equation. You find m. You use m to find the general solution. So from the general solution, now we go backward. We look at these and we determine what m is. So you know, if you see an x in front of it, you know that m repeats, right? So we know what m's are. So once you know what m's are, then you can just go m plus each number and you multiply them out, you get the auxiliary equation. And then from there, you can get the differential equation. Okay, so let's go over here and see if we can do this. So from here, you know that this is gonna imply a second order, right? Because there are two solutions. So it implies second order differential equations. Okay, so from here, what is m sub 1?
M plus 4?
No, I asked you for m sub 1.
Oh.
-4.
-4, good. And what is m sub 2?
-3.
-3. So let's get the auxiliary equation. Now, so this is from algebra that you learned, intermediate algebra, because this is like these are like the solutions of a polynomial equation. So to get the equation, don't you take like m minus -4, which is plus 4, and then m minus -3. Okay, and then you multiply out, you get m squared plus 7m plus 12. So that is the auxiliary equation. Okay, so that is so what is the differential equation from there? Y double prime 7y prime plus 12 equals 0. Okay.
So that one was ideally just moving backwards from what we
Yeah.
have. Okay.
Yeah. So this, so is the homogeneous differential equation. Okay, that we are looking for.
Professor,
So far, it is not hard at all. Okay, so far in chapter 4. All right. Yes, questions. We run out of time, but I can answer a question.
yeah, shouldn't that be 12y instead of just 12?
Oh yes, 12y. Thank you. I got too excited, right? It should be 12y. Okay. All right. So we're done. So basically, oh, that's great. We moved this one up. We get one extra day that we can use that day later on when we get into some complicated topic. Okay. All right. So any questions? If not, then I will see you all on Wednesday. Okay. You have a good night.
Have a good one.
Yeah.